Now we will see design of digital IIR filters. So earlier we have discussed about the analog design of analog IIR filters. So in that Butterworth we have seen, and now design of digital IIR filters we will see. In that also Butterworth digital IIR filters we will see. To design this one, there are two methods actually. So one is, we can call it as IIT, and another one is BLT. So IIT means Impulse Invariance Technique. Okay, so it is Impulse Invariance Technique. Invariance technique it is, and it is bilinear transformation. Okay, impulse invariance transformation also we can call, or impulse invariance technique also we can call. It is bilinear transformation it is. Okay, so now we will concentrate on this, and next we will concentrate on this BLT. Okay, so we will have a brief discussion on this, that is how to use how to apply impulse invariance transformations, okay, for this systems. So now we will see step by step design of this digital filter by IIT procedure. Okay, steps to design of digital filter by IIT, that is impulse invariance technique or transformation. So now first step, for a given specifications, so if they have given Kp, Ks, OMP, OMS, then it is our duty to form this one in a transfer function, that is analog transfer function, which is called HA of S. Okay, first this we have to form. Suppose if they have given in most of the question papers, they provide us this transfer function. In very few times they have not, they'll ask us to find out, we supposed to find out this. Okay, HA of S, which we have already discussed in previous video. Okay, so now what we will do is, so first step is to have this transfer function. Then second step is to select sampling rate. Okay, select the sampling rate of the digital filter, So usually digital filter T seconds per sample. So this is usually they'll provide us what is the sample there, we suppose for what a sample we have to find out. Okay, so then third one, we'll express the analog filter transfer function as the same of single pole filter. Okay, that is HA of S is equal to summation of K is equal to 1 to N, and then Ck divided by S minus Sk, where Sk is nothing but our poles. That we have to remember. Okay, so we in earlier case how we have calculated this entire HA of S, that procedure entirely we have to apply, but in most of the question papers they'll provide us directly. Okay, that is advantage what we have. If not, we have to first find the HA of S analog filter. Next we have to compute the Z transform of the above system. Okay, so by using the formula, H of Z is equal to summation of K is equal to 1 to N Ck divided by 1 minus e raised to Pk T into Z raised to minus 1. This formula we have to apply. So it may be a bit confusing for us, like how to apply this. Let us see the example. It will be very easy for us to analyze and to understand it. Let us see this example. For the analog filter transfer function, H of S is equal to 2 divided by S plus 1 into S plus 2. Determine H of Z using IIT method. Assume T is equal to 1 second. So they have given already a transfer function, and they have already given the sampling rate as well. So now directly we have to apply this IIT method. So for this what we have to do is, formula for that is h of z is equal to summation of k is equal to 1 to n ck divided by 1 minus e raised to pit into z raised to minus 1. This is the formula for us. So we have to express this system into this form. So to get that, so this is in multiplication form. So now what we have to do is we have to get it in factorial forms. So to do so, we have to go ahead with the partial fraction. Okay. So how to follow this, we will see. So h of s is, they have already provided h of s, which is equal to 2 divided by s plus 1 into s plus 2, right? So s plus 1 into s plus 2. So now we will have this, how many factors are there? How many roots are there? 2. So they will have a divided by, that is 2 divided by s plus 1 into s plus 2 will be equal to a divided by s plus 1, one factor, and another one is b divided by s plus 2, another factor. This is what partial fraction we will do, and we will calculate a and b. So for this, what we have to do is make this, we are very familiar with this. Okay, so then it will be cross multiplication. So a into s plus 2 plus b into s plus 1. Okay, so here we have left hand side s plus 2 divided by s plus 1 into s plus 2. So numerator both the sides is going to cancel. So only remained with 2 is equal to a of s plus 2 plus b into s plus 1. So in this case we have to calculate a and b purposely by making s is equal some one factor or one term equal to 0. So for that we will calculate what is a is equal to what. For that we have to make b is equal to 0. To make that b is equal to 0, what value of s has to be substituted? Put s is equal to, okay, we are purposely calculating partial fraction. So what we have to do is to calculate a, b has to be made 0. How to make b is equal to 0? What factor of, means what the value of s if you fill, so that will make b is equal to 0. So this plus 1 is supposed to be 0. It means it is minus 1 plus 1 will be 0. So put s is equal to minus 1. So both the sides we have to put s is equal to minus 1. Since there is no s in the left hand side, let it be a of s is minus 1 plus 2. We are just substituting s value here. And plus this term, anyhow we are making it purposely, it means obviously its value goes to 0. Then we have a is equal to 2 minus 1 is 1, so which is a equal to 2. Similarly we can calculate b as well. So to calculate b, what is the value of b? By making a is equal to 0. What value can be substituted so that a term goes to 0? So then s value is supposed to be substituted with minus 2. Okay, therefore LHS is remains the same, 2 only, there is no s part. So a term is, we are making 0, anyhow it will be 0. Next, plus b of minus 2 plus 1. So 2 is equal to minus 2 plus 1 is minus 1 of b, which is b is equal to 1 by 2. Okay, sorry, minus 1 by 2. Sorry, this is minus 2. Okay, its value becomes, b value is minus 2. I'm sorry. Once we get that, a is equal to 2 and b is equal to minus 2. Let us put this one in the form of h of z is equal to what we had, a divided by, which is 2 divided by s plus 1, and this is plus minus b which is minus 2 divided by s plus 2. This we had, and now what we will do is we will simplify s plus 1 minus, so this one we will take as minus 2 divided by s plus 2. So now what we have to do is this, these things we have to start expressing in this form, which is let us express this one in this form, a1 divided by s minus p1. This is nothing but our p1 is nothing but our pole. Okay, so that's what we have to get the value of poles. So here if you put, this is a1, okay, a1 divided by s minus of minus 1. Okay, so minus, it is a2 we can consider, s minus of minus 2. So minus 1 and minus 2 are our two poles, which is p1 is equal to minus 1 and p2 is equal to minus 2. Okay, these are our poles. Therefore now we can express according to our formula, h of z is equal to ck divided by summation of, okay, summation of k is equal to 1 to n. So 1 minus e raised to pi into t into z raised to minus 1. Here we have only two terms. It means n will be 2, 1 and 2. It will be two terms we have to express, which is h of z is equal to a1 divided by 1 minus e raised to p1t into z raised to minus 1 plus a2 into 1 minus e raised to p2 into t z raised to minus 1. Okay, we are just expressing in that form. So now we know what is the value of a1. a1 is 2 divided by 1 minus p1 has to be expressed like, you know, e raised to p1. p1 is minus 1 into t z raised to minus 1. Okay, plus a2 is minus 2. Okay, so I'll write here only that one, minus 2 divided by 1 minus p2 has to be expressed as e raised to minus 2t into z raised to minus 1. Since we know t is equal to 1 second, they have already provided. Okay, so therefore it is 2 divided by 1 minus e raised to minus 1 into 1. So 1 e raised to minus 1 into z raised to minus 1 minus 2 divided by 1 minus e raised to minus 2 into 1. So minus 2 into z raised to minus 1. Therefore 2 divided by 1 minus e raised to minus 1 value we have to do. It is 0.368 into z raised to minus 1 minus 2 divided by 1 minus 0.135 z raised to minus 1. E raised to minus 2 value we have to get. Now we can just simplify this. So once you simplify, you will get the values like, you know, cross multiply these two, which is 2 into 1 minus 0.135 into z raised to minus 1 minus 2 into 1 minus 0.368 z raised to minus 1. Okay, divided by 1 minus 0.368 z raised to minus 1 into 1 minus 0.135 into z raised to minus 1. If you simplify this, expand this, it is 2 into 1, 2, and 2 into this, z raised to minus 1, and minus 2 into 1 is 2. So plus 2 and minus 2 is going to get cancelled. If you simplify this, we get h of z is equal to 0.466 z raised to minus 1 divided by 1 minus expand these two. Okay, so 0.5032 z raised to minus 1 plus 0.04976 z raised to minus 2. You can please check the values of a calculation. Okay, so what we have to do is, in IIT, that is impulse invariance transformation, which is a digital designing of a digital filters. So for this, what we have to do is just h of z we have to calculate. To calculate that h of z, we need ha of s. Most of the time they will be given. If not, we have to use that process, calculating number order of the filter, and after this we have to calculate ha of s by using this number of poles and all, which is ohms e raised to n divided by summation of s minus sk we have to do. Okay, so sk can be, if n is odd, we have to use 1 at an angle k pi by n. Okay, so and if it is even, other formula we have to use, and then form it, then calculate ha of s. So in the same way, to calculate h of z, as we said, IIT say, what we have to do is, whatever ha of s we have, that forms, that transfer function has to be expressed in factorial form, this plus or minus this. Okay, so and later what we have to do is, number of poles we have to get it. So it might be s plus 1 or it might be s minus 1. So if it is s plus 1, we have to make s minus of minus 1. If it is s minus 1, we have to make s minus of plus 1. So here pole is minus 1, here pole is plus 1. In this way we have to express. So we have to identify P1, P2, P3, and then we have a formula which is called h of z is equal to, we can call it as a divided by s minus P1. We can use a1 divided by s minus P1 plus a2 divided by s minus P2 and so on. So later what we have to do is a1 divided by, in the place of this has to be expressed e raised to sorry, 1 minus e raised to minus p1 into t into z raised to minus 1. It is plus, okay, it is plus t. Okay, 1 minus e raised to p1t into z raised to minus 1. So similarly, a2 divided by 1 minus e raised to p2t into z raised to minus 1, and a3 divided by, and so on. Okay, so now target is to calculate what is p1 and what is the p2. That to calculate p1 and p2, we are going to use partial fractions to express in the form of like in a factor, in the form of summations.